Hi, I just want to show you some simple Matplotlib functionality for plotting data. So let's first import Matplotlib, pyplot. It's a bit of a mouthful. We'll also be using NumPy as NP. Okay. All right. So first of all, let's create some data. So I'll create data using lin or linspace. This basically will create a range of data. Let's do a sine wave, of course, like we did before. np.py will create let's create 64 data points. np.py is literally pi. So if I go import numpy as m, oh, hold on. Let's copy this over here. So if I go, just to show you, if I go np pi, I literally just get pi, okay? So it's just a scalar number. So if I run this, this gives me the x values, the y values. Because NumPy works with arrays, a lot of the operations are array-based, so there's an array-based sign. So I can go np sine x. If I run that, I get an array of y values at the x values to give sine. Now I can do a plot, and plotting is really simple. I just go plot plt plot xy, and then what you should do is put a show at the end. And what show does is whatever's been stacked up to plot, show will empty that queue to the user, so you'll see the plot. Okay, so strictly speaking, nothing gets plotted until plot show, although you can leave it out here because when the script finishes, it'll do the plot. But it's good practice to have a plot.show, and we'll see why that's the case shortly. So let's run this, and we get our sine wave. Okay, so why don't we start embellishing it a bit with a label, radians, okay, and then the y label, I'll call that y-axis, and then plt, might as well put a title in, call it demo plot. Okay, I can run this, and I get those. So you might be thinking, hold on, these labels are a bit on the small side. Let's have them a little bit bigger. So you can do that. So you can go font size. Do 16, I think is a good, that's in points, so that's a good size. They are radians. Let's copy that over to the y-axis as well. Do the same for the title, but if the title, make it slightly bigger. Okay, so now that some of you know a little bit about LaTeX, you'll start to realize that LaTeX pops up all over the place, especially on the web. Pretty much all math rendering on the web is using LaTeX. So if you ever edit for Wikipedia and you need to put in an equation, it'll use the LaTeX format. And the same goes here. If you want to put an equation here, you just put $, put your LaTeX expression, and then finish it off with $, and you'll get that rendered there like that. Okay, which is quite useful. The other thing you'll want to do is probably save it to, say, let's save it to a PDF. Oops, PDF. Now, can't see. Yeah. One thing that happens here, though, is when you start changing font sizes, you start getting clipping of the text when it's saved to a PDF or PNG. To avoid that, you can call a thing called tight layout, and that'll make sure that all the labels are inside the plot window and don't get clipped. So let me run that. So that actually ran. It gets saved to my current directory. My current directory is Tellurium. So let me go here. Let me bring up the PDF. And there it is. Okay. Now, if you just want a quick one, let's say just a quick PNG, you can actually right click over this, copy the image, and then you can go into Paint, for example, paste it, and you've got your Paint there. Because the problem here is that the resolution is pretty bad. You can improve the resolution. I think there's a DPI option where you can increase the number of dots per inch if you really want to use PNG. but PDF is the safer one to use. Okay, so that's how to do a quick plot there. What happens if I wanted to change things, like I wanted to change the color? So I can change the color by modifying the plot command. Let's say change the line to red. To do that, I just put quote R quote, and I'll get it in red. There's a list of colors you can find online. But if you want any fancy colors, you have to use hexadecimal, which gives you red, green, and blue numbers, which you have to specify. It's a common thing they do on the web as well for doing colors. What happens if I wanted markers on top of that? Well, I can just add a marker there by putting an O. That'll be a round filled circle, and I get markers. There you go. But you notice the line has disappeared. To recover the line, I just put a dash, and that gives me the line back. If I didn't want a dash, if I didn't want a line, but I wanted a dash, let me reduce the number of points so you can see it. If I go to dash dash, I get dotted line instead of a single line. If I remove the marker, of course, I'll just get the dotted line. What happens if I wanted to plot more than one graph on the same plot, or more than one plot on the same graph? Not sure which way around it is, but let's do a sine, a cosine, and a sine wave. So I'll generate two sets of data, and all I have to do is put in two plots. One will be for the sine wave, one will be for the cosine wave. Let's change the color to blue for the, and we'll make that a single line for the cosine. There you go. So now I've got a cosine as well. You may want to put in a legend. You can add labels to these. So that's my, oops, not there though. I can add a label to this. So let's go label equals, what should we call it? Sine. And then the other label we'll call cause, okay? And if I run that, nothing appears, too many brackets. If I run this, nothing appears to happen, right? So to actually activate the legend, you have to go plot legend. All right. Now if I run it, you'll see there's the legend there in the top corner. There's options on legend where you can change the location. If, say, your legend is obscuring something important, you can change the location. So that's how you can plot lines. What else do you want to know? What happens if you want to change the size? Let's say it's on a bit on the small side. You can change. Let's do it up here. You can go figure fig size equals, and I can make it a bit bigger. Let's say 8 inches by, I think the default is inches, 8 inches by 6 inches. Run that, and it's slightly bigger. You can notice that you can see the straight edges in the lines there. That's because I didn't use many points. Let's increase the number of points back to, say, 128. Run. Okay, now it's smooth. What happens if you don't like that the line thickness is not great? You can increase the line thickness. Let's do that one. So the dotted lines thicken up, and you can do the same for the other one. Okay, let's go crazy here and put 9. You get a very ugly blue thick line. All right. So that's some basics then on using Matplotlib. It's a very rich library. You can do all sorts of things with it: 3D plots, histograms, bar charts, and so on. Anyway, that's enough for this one. Thanks.